stop. Whether I can see. Let's do this. Make y the subject first. Rearrange. So this cancel. 1 is 6. Okay. So this is 6. Therefore, the line that you have to draw is y. Okay, that missing x here is equal to minus simplify 2 over 7 x plus 6. Okay. Now, y-intercept is 6. So use the different color. Y-intercept is 6. Now, to find the second point, you can make y a subject. Okay. You can make y the subject equal to 0, and you find x value. That's y. That's x-intercept. Making y 0 and find the value. The other point will be somewhere here. When y goes to 0, what is the x value? Okay, but I can also choose any number. If I choose x equal to 7, why? Because if I put x 7, it can cancel out. Then I know what's the y value. So it's okay. As long as you know exactly what you're doing. Minus 2 over 7 times 7 plus 6 cancel, become 4. So point 2 is actually equal to x is 7, y is 4. Okay, let's go and mark point 2. X7. Okay. Y equal to 4. Wait, it seems to be a problem. X7 y equal to 4 is somewhere here. Okay. X equal to 7, y equal to 4. Now, I'm going to join them. Go back to the X name. Draw the line. So it's from here. All the way. Now, so I draw the line. Now let's go back to the shading first. It's less than. That means the wanted area is below the line. So the above is the unwanted area. So let's go and shade. Okay. Now leave this space to write the original equation. Remember, no inequality. So it's 6x plus 14y equal to 84. Okay, now if you check the whole graph, the only area where there's no shaded inside is here. Okay, so this is R, the wanted area, the wanted region or wanted zone. So we're going to get the answer from this part here when we answer this question. Okay, so we are done with the third part of linear programming, putting the line onto the graph, shade the area, name the line. Okay, so we're going to look at this. This is E. Okay, now let's look at it. Find the smallest cost when Peter want to buy a total of 9 trees. Okay, total of 9 trees. Bear in mind, total of 9 trees. So you see, from here we want to find a place where the total sum is equal to 9 trees. Okay, you could have 5 on this. This is the palm tree. Okay, this is the apple tree. Wait. X is the palm tree, and then the Y is the apple tree. Here X is the palm tree. Okay, so now in this area, to get a total of 9 trees, you can have, let's say for example, 5x, which is the palm tree, plus the 4y, which is the apple tree. But then you want the lower cost, so we will try to get which is cheaper. The palm tree is cheaper, so we want to increase the number of apple tree. The palm tree, X is the palm tree, and then decrease the number of apple tree, which is Y. Okay, so now what you have to do is you look at this region here. Okay, what you have to find is 6 and 3, 5 and 4. Okay, this is palm, cheaper. This is apple. Okay, now there's no such thing as 5 1/2 tree, 4 1/4 tree. So you have 5x plus 3 there. Because of the lowest cost, we want to keep the palm tree as number of palm tree as big as possible. You could have 6x plus 3y. Okay, you can have 7 pieces of x plus 2 pieces of y. Okay, so as this increases, because it's cheaper, it's more expensive, so the cost will decrease. So we look at 7x, but remember this area, okay, is the wanted area. So you can see the maximum you can go is somewhere 6 palm tree. X is a palm tree, and then you have 3 apple tree. This case, okay. This is a rough drawn of the line, so not really sure whether it's right here or not. Okay, but for the matter of explanation, if I take 6x, which is 6 palm tree, plus 3 apple tree, that will give me the cheapest. Is this the point? Okay, so this is the point. See, x has the maximum. I can go up, have less x and more y, but then that will increase the cost. But he's asking for the smallest cost. Okay, so therefore, the smallest cost in this case is 6 palm tree. Palm tree is actually, the cost of the palm tree is actually 6. Okay, plus 3 apple tree. The cost of the apple tree is actually $14. So add together 36 plus 42. Okay, that should give you an answer of $78. That is the lowest cost you can use in order to meet all these constraints, all these